Good afternoon, my dear friends. Welcome back to my YouTube channel. Today I am going to discuss a lead code problem on March 23rd. Lead code problem is number of ways to arrive at a destination. We should find out the number of ways from the source to destination. Source to the destination. Number of ways. We should find out the number of ways. Today I am going to discuss only the concept. Code will be given on the description. You can see the description if you want code. I will clearly explain the what is the brute force method and the pseudocode for this problem. For this problem, they have given to find out the source to destination. We should find out the source to the destination, the number of ways we should find. That is, here 0 is the source. First of all, 0 is the source. 0 is the source and the n minus 1 is the distance. We should find out the shortest amount of time. They have said that here we should find out the shortest amount of time. To find out the shortest amount of time or the shortest amount of the distance, we have one algorithm called as Dijkstra's algorithm, which is the most important. In our previous classes, we have also already discussed about in the DA, we have a Dijkstra's algorithm, which is used to find out which is also called as single shot, single shortest path. Let us see an example. Here we have the source as 0 and the destination as 6. Initially, we keep the distance array. We calculate the distance array and we keep the distance array as all the infinities. And we go on update the distance. We calculate one distance called as calculated. If it is calculated value is less than distance of adjacent node, we update the value. Let us see when to update. If calculated value is that is the what does the calculated value consist of? Calculated consists of previous node value plus the adjacent node distance. Adjacent node distance. These two are by calculating these two values, if we get the calculated value as less than, so we keep those value as the updated value. So here we can see initially we kept all the values as infinity and we go on updated the values. For every part of the adjacent node, we go on update the values. After updation, we get in 2, 5, 6, and 7. Due to my microphone issue, I have previously recorded the video, but this video doesn't contain the audio, so I am re-recording this video. Here we have seen that we calculated the distance. What are the possible distances? Calculated distances from the source to the destination. Now we have gone through the distances. The possible distance, the possible waves are one possible way is this, another possible way is this, another possible way is this, another possible way is this. These are the possible values in which the distance will be least, that is 7. All the possible values are 7. The number of possible ways are 1, 2, 3, 4. 4 number of possible ways. That is what given in the example. Now, how can we find out the number of ways? Number of ways here to get the approach easier, we we make similarities with our daily life situation. Let us suppose take an example. If you are traveling from Hyderabad to Anantapur, what are the number of possible ways? The number of possible ways are we can go to come from Raichur, we can come from Vijayawada, we can come from Tirupati. The number of possible ways are three number of possible ways. Similarly, we in this to find out the ways let for this node, the number of total possible ways are only one. That is only one number of possible ways. Let this all be the six ways, but the number of possible ways are one. For this node, what are the possible ways? The possible ways are six number of ways. That is from this also one path, this is 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 one path. So there are number of possible ways are six number of possible ways. So similarly, we compare this with for the destination node, we should calculate the previously number of ways. Previously number of ways. For this node, the number of possible ways are, let me change the color. The number of possible ways are, this is the one number of possible way, and this is the one of the possible way. For this adjacent node, the number of possible ways are two. That is from this node. We calculate the ways. In this way, we calculate the ways. We keep an array called ways. We keep an array called ways to keep track of the number of ways. Initially, for the first node, we keep the first node number of ways as 1. We keep number of nodes as 1. We go on calculate the ways. That means to the adjacent node, if the calculated value is, if the distance and the previous and the calculated distance, if the calculated distance and the distance are equal, we keep same value as the ways. That is 1. If you go through the situation, that is if both are equal, then we keep the same value of ways. If if the calculated distance is less than the previously calculated distance, we we add this ways, we calculate the previously calculated ways and this calculated ways and this ways. That is, let us see this example. Here, the from this way also we are getting 6, from this way also getting 6. So we add on this two ways. We add on this two ways. That is, the number of ways are 2. So for this adjacent node, we get the number of ways as 2. I hope this point is clear to all. And this point, that is the, if no number of ways calculated, no number of ways, so we get the value as only 1. We override this previously calculated as ways as this base. This is the approach. Here, for Dijkstra's algorithm, we use priority queue. Why do we use priority queue? Because we should calculate the lesser distance. We should select the lesser distance node. At first, we should calculate the lesser distance node, in which we can get through the minimum heap. The implementation of the minimum heap can be done using priority queue. Here, this code will be available down. Whatever I have discussed in this code, in this brute force or the pseudo code, the same representation is represented in the form of the code. So thank you, my dear friends. I hope this pseudo code is easier and Graph's Dijkstra's algorithm is easier and easily understood by everybody. Thank you, my dear friends. Please subscribe to my YouTube channel and share with your friends. Thank you.